Yeah, thank you and welcome. I usually thought that the most difficult talks to give at conferences are either the talks after lunch, when everybody is sitting there in some kind of soup coma, or the very first one on the second day after the social event, because usually it means people are not really attending carefully. Let's keep it in a simple way. Today I learned that it's also hard to give a talk after James, because James really does entertaining things around here. And so you had the entertaining and fun part already, so now it's me doing the boring stuff here. So welcome to the boring stuff of, yeah, some recommendations, some thoughts that I have on how to do DevOps in a containerized world. One disclaimer up front, I will be very harsh in some of my comments. And you might not be say, no, we're not comfortable with what Martin is doing, but what I want to achieve is that you start thinking on how to do the stuff, and that is the reason why I put harsh words on it. So, who am I? My name is Martin. I'm CEO and co-founder of Example 42. We still do lots of Puppet development for customers. We also help customers on their way to how to get to this DevOps thingy, which tools to buy, how do we build DevOps silos and stuff like that. No, never build silos. We help companies finding solutions for implementing DevOps in their infrastructure. We are a huge fan of automation, regardless what tool you use to do automation. The big thing is doing the automation at all. That's the top thing you have to do. So I'm going to talk about DevOps, and I decided to have it in a 3 pattern that I say, first, what is it that we have in classical DevOps? Let's call this heritage infrastructure, for example. So old legacy platforms maybe. Some customers will wonder what is old legacy heritage does mean. We still run our DB2 instance on a Spark-based hardware, for example. So some companies haven't adopted to this modern technologies of containers and container orchestration. So first for the classical DevOps, then I will dig into DevOps in the container world, and then DevOps in the container orchestration world, and I will see what are the differences among there. So the first thing is, why did we have classical DevOps? Why do we have DevOps at all? The basic thing was there was somehow a change in development from waterfall to agile development. So waterfall usually means 6 months of planning, 6 months of coding, 6 months of releasing, 6 months of fixing bug, and then you repeat the next 2 years and you have your new release ready. Companies learned that by doing it that way, it is difficult to react fast on customer feedback, for example. The website is not that responsive, it doesn't look that nice, it's hard to read or stuff like that. So development decided to go for a more agile process, saying we slice down the whole big thing we have to do into multiple single little components, and we will release each of these little items. Well, what was the issue by then? Ops was still used to having 2 years release cycles, so they planned for new hardware, for new virtual machines, and everything took time. This is the point where we said, when we run release cycles faster, we need a tighter collaboration between the application development and the operations team. Within that perspective, we also changed the mindset, how we see other departments. So in the past, it was always a fighting. There's development, there's operations. Usually when you ask one about the other, they will always tell you, oh, these are nasty people that don't know how to do their job. So the mindset shifted them, saying everybody is a customer in a company. So not only people from the outside paying the company, but also inside the company, we deal with customer-oriented development and setup of systems. So product. The product owners that do they have the vision on what is it that we want to have in the next release. They are a customer to the development department. So that's the customer that orders something and he gets paid for it. Or at least you get paid for it as a developer. The same is from ops perspective. Development is a customer. So development department is asking for new hardware, for new operating systems, for newer releases of operating systems, for newer Java versions, whatsoever. Whatever they require to run their application. So from ops perspective, development is a customer. For both, they have the security department saying, ops says we need a security scan of the platform. Development says we need to ensure that the planning of our new application, that we already take care on security. So security is a customer for both. That makes it a little bit more easy to deal with each other, because usually you will never fight a customer, you will never blame a customer, and you will never insult a customer. That makes it, from a cultural perspective, better to deal with other departments. What I really refer to as DevOps is the DevOps kata. So who of you has done or knows about martial arts? Almost a couple of people, okay. So martial arts is something like karate, judo, and usually you go to a dojo, this is the training center, you enter there, and then you do your kata. The kata is the permanent repeating and improvement of predefined movements in martial arts. Within DevOps, we have a same pattern. We have to repeat the stuff that we did, we have to review it, and we have to improve it, permanently improving it. That's the reason why I like DevOps being described as a kata. The problem is, in English, the word culture doesn't start with K. That makes it a little bit difficult explaining that to English native speaker. In Germany, you spell it with a capital K. So the first thing within culture, within DevOps, is a culture, a change, a mind shift change, how to deal with other departments, how to deal with other technologies. The next thing, which is highly important, is doing automation. Whichever tool you have found is useful for you and your team members, wherever do you have your level of expertise available, use that tool where you're comfortable with and where you have expertise with. There's another wording that describes DevOps at CAMS, C-A-M-S. They mean to culture, automation, metrics, and sharing. Metrics and sharing is something that I put together into transparency. So transparency is everything that you can visualize, and you pass on these data to whoever needs the data. Finance wants the data to see how many transactions did we have in the last 24 hours. So just provide data for them and do that in a transparent pattern. Ops wants to know about cluster usage, network usage. So just provide the data and use them. So this is what I put together, metrics and sharing, into the concept of transparency. And based on top of that, this is what I'm missing when people talk about DevOps being CAMS, is the agility. So everybody works in an agile pattern. Don't do huge deployments, don't do long-term plannings. Cut down the big thing you want to do into single little steps that you want to achieve. And this is the focus. I will now dig through the whole talk that I always refer to. Do we have something like kata also when it comes to containers and container orchestration? When we do standard DevOps, we usually see a pattern that people say, we need a shared tooling environment. So you don't want to have multiple and maybe different version control systems around. You don't want to have hundreds of systems doing metrics. One development department using Prometheus, another is using Elasticsearch. You want to have one single tool that allows you to share the data, that allows you to collaborate, and that allows you to even support new employees by just going to somebody in the department, even a developer when you have a new system engineer, and explaining him how this Git thing is working. The next thing you want to have, regardless whether you're really a hardcore ops person or whether you're a developer, you want to have a CI/CD system. We now do automation, and usually that means we run infrastructure as code. Everything that is code must be tested somewhere, somehow, and this is where the CI system in combination with Git comes in place. We also have not only shared toolings. In a classical DevOps approach, we have shared responsibilities. So maybe the hardware is not yet shared. So that's basically, if you have a data center somewhere, well, we are in Berlin here, think about having a data center in Leipzig. You will not travel every day to Leipzig to do something in a data center. You will have remote hands that does the real dealing with the hardware. But already starting on the operating system level, and maybe some fine-tuning of the operating system level, is something where we collaborate with the application developers, identifying what kind of sysctl settings do we need for this application to work properly, what kind of SE Linux can we do on a system so that the application works properly. And of course, it's the application, because usually the application gets developed by the developer and is run by the ops people, but usually when the application stops working, they need a developer to debug what's wrong with the application. So that's what I call that shared responsibility. When it comes to tooling, And there's companies around that say, yeah, you can buy our DevOps toolchain. Oh, funny, what's that? Never heard of a DevOps toolchain. Yeah, that's something like version control. That's something like automated virtual machine management, whether you do VMware, libvirt by yourself. That's out of scope. It's just a VM management solution. Just try to find a solution that is automatable. You might do configuration management, saying, I have a base OS system. That base OS system must be adopted to our security regulations. It must be configured according to the application. You want to have something like secrets management. You don't want to have some passwords floating around or lying underneath someone's keyboard or pinned to a monitor or something like that. You want to have somewhere a place where you can securely store data inside, especially when it comes to passwords, certificates, or tokens. And last but least, and this is not a misspelling, you want to have something like CI/CD/CD. Why CI/CD/CD? So everybody's referring to CI/CD. That's not enough. So CI is continuous integration, which means we test the stuff that we have built, that we have developed. We build it and we test it. The next CD is the continuous delivery, which means this, when we have built our artifact, we just package it and we stage it somehow on a repository or artifact system. But just making it available will not deploy it in production. And that's the last thing, that's the last CD, that's the continuous delivery of that delivered, the continuous deployment of the delivery into production systems. Usually people don't do this because they are afraid of breaking their platform automatically. We need to find ways to identify whether the platform with a new release is still healthy or not. The problem, the learning curve. Oh, how do I do, we had this in the morning, do I do trunk-based development? How many commits am I allowed to have on a feature branch? My perspective, you may have one only on a feature branch. You have to learn rebasing, squashing. You have to deal with merge conflicts. You have to deal with multiple things which are completely new to people who never worked with Git before. And be sure, there are many, many people who have no experience with Git. Who of you says he's good at Git? That's just a couple of people, as I mentioned. So everybody who's not good at Git might somehow be in a situation where he says, now it would be nice to be good at Git. So they look for maybe the Git handbook, they look for other resources on the internet, they Google their problem and hope to find a solution. The big thing that also changes when it comes to automation is that we stop doing things manually on a platform, but instead talk to APIs. APIs which give us functionality, what is it that we want to achieve on a platform. But dealing with APIs is uncommon, at least to ops people. So they have to take care about, okay, how do I get a token? Do I have to show a certificate? Which rights do I have with that token and that certificate on that specific API? So it's a paradigm change, how to see platforms and how to work with platforms and how to do your daily business job. What else can we say to heritage standard DevOps in classical environments? We see it more and more companies adopting. At least some companies already understood that they don't hire DevOps engineers, that they don't build their DevOps silo, that they don't build DevOps teams, but understand, okay, it's a cultural change. Sometimes companies fear that they bring this change to their teams because they say, oh, if we tell people they now have to work in a different way, they have to think in a different way, they will refuse, they won't adopt, and instead they will just, well, either leave the job, but we need them because they know about the platform, or they will refuse to collaborate. Some companies we've seen doing it in a way that they have founded startup companies where they can work in an agile DevOps style pattern and still do the old waterfall stuff inside their old existing company. It's based on known principles, so people know about this tooling, and yeah, we see it more and more adopting. So when it comes to DevOps, one thing changes dramatically. Not for the application developers. Application developers are still there to develop application. They have their field of expertise in either Ruby, Java, Golang, whatever language they have their expertise in that area. They know how to code, they know how to do backends, they know how to do front ends. But it differs completely from an ops perspective. In the future, you will not have system administrators anymore. System administrators log in into systems, change something, analyze something, and log out again. They do things manually. When we start doing automation, I prefer talking about infrastructure developers. These are the people that provide interfaces to APIs, that automate their platform, the people that do the configuration management, the people that somehow build the, let's say, the secrets solution that you have around. So they developing the infrastructure. And the next thing, of course, you want to have in a team is a security developer. So a security person who knows about software development, who knows about OS management, and who knows about OS patching, for example, and about operating system security. I suppose that the security developer is the person that you are hard looking to find, because some security people know about security, but not about development, and nor about operating systems. Okay, so this is the classical DevOps. This is something we already do for quite some time. When did the term DevOps arise? Give me a guess. Who's guessing it's more than 5 years? More than 8 years? More than 10 years? More than 20 years? It's around about since 10 years approximately when the term first showed up at I suppose it was somewhere in Ghent, but you're nodding. Okay, it was in Ghent. So that's already established and people are doing it. And now we have this new thing where people start thinking about, oh, it's so hard to do the stuff on a real operating system. Can't we isolate things? And this is the point where we come to containers. So within containers, we can say, due to the collaboration of developers, application developers, and developers, infrastructure developers, the application developers learned how hard it is to maintain a system in a proper state, excluding its application. So they made a decision on isolating the operating system from the application and placing the application just in somewhat what we might call a change root with additional things around. And this is what a container is. What they want to achieve is separation of concerns. That they say developers, application developers, they develop the application and the application is stacked inside a container and you just have to spin up the container and the application is working. So they don't have to deal with anything underneath which is somehow an operating system or a container runtime engine. This is done by the infrastructure developer. They build the container platform where you are able to run containers on host containers inside like a registry. The thing is, what application developers need to learn is they need to adopt to this modern technology. They have to build into their application something like health checks, metrics. I want to know how long did this request take from coming inside until the other system has answered the request. I want to see when I do an upgrade on a container, do I somewhere have a timing regression in my application? That's of high importance now, because you can't look really inside the container because usually you don't have a shell in the container. So you need that the container pushes information out of the container, which we usually call metrics. Well, containers have the benefit that developers say, it's so super easy to package our application. It's so super easy to stage. It's super easy to build a new release which fixes a bug. We want to have that on a system. Infrastructure developers now struggle, okay, but how do we run containers? I usually make the joke that the developer is showing up with his laptop and tells us, see, my application is working on my laptop. And the big question is, how do we get that laptop into the data center? And how do we scale that laptop? So containers need somehow an infrastructure. So when we have an infrastructure, we still need infrastructure development, which means we still have the need for infrastructure developers. When you're doing containers, you will immediately learn that software-defined networking is used everywhere. So SDN, as we call it, software-defined networking, is a must. You must deal with the concept of what is it that does mean. You have to get rid of the thinking in classical systems that have an interface and an IP address, and maybe you do bonding on the interfaces, maybe you have virtual interfaces. Stop thinking in these terms, start thinking in software-defined networking terminology. And what you also see is containers needs orchestration. So like maybe we already did in the past, how do we do an upgrade on an HA cluster? Well, usually we update the passive node first, then we switch over from the active to the passive node, so the formerly passive node now is active. We check whether everything is still working, and then we can update the first cluster part. With containers, you don't deal inside containers, but you maybe want to run containers. Maybe you want to run them multiple times because you say for load reasons and high availability reasons, I want to have multiple containers placed behind some kind of load balancer technology. So containers need an orchestration so that you know how many of these systems do I want to run. The next thing I'm interested what is Isinga doing in that case is you're no longer monitoring systems. You're monitoring services. You're no longer interested whether one single component, one single container out of 10 that do the same is no longer working properly. You want to know about that it's no longer working properly so you can tear it down and spin it up again. But you're no longer interested in, at least from the application perspective, what is the hardware underneath doing? That's something where the infrastructure developer want to know about. How much CPU usage do I have? How much saturation on the network do I have? What you definitely want is something like a discovery. So you want to identify how many containers are running on my Docker-D instances. We introduced Docker for CI/CD at a customer in Berlin. And first we asked security, is it okay to have in the CI/CD platform a Docker daemon running? And they mentioned us, yes, but don't go out in the internet, build an internal registry, and then you are allowed to run it, and please run them unprivileged. We had the issue with SSH and logging in as root, so we were, okay, as long as it's only on CI system, then it's okay to run even unprivileged container, but one only, and not multiple ones. So we had the okay from security, and we were doing CI/CD with Docker. So using an instance to spin up an instance as a Docker container, test the code of our configuration management, and in case that it's working successfully, or even if it's broken, tear down the container again and deliver the result back to the merge request. It took us around about 1 week to identify, oh, the registry service has issue with storage because developers were learning, hey, we have Docker-Ds around. So we can spin up containers. And developers were somehow saying, that's cool, that's nice, let's build containers. And they were building containers over and over again. Gigabytes of containers grew into registry. Expect something like that will happen, that when people recognize they have the possibility of using the tool, they will use the tool. And when they use the tool, you still want to have somehow an insight on what is it that I'm running now at the moment. You have no idea because your ops is no longer, or infrastructure development is no longer responsible for spinning up containers. This is the hand of application developers. But you want to get an idea what's up in my platform. I already mentioned the metrics, and when saying in-depth, I mean system metrics and application metrics, and even business logic metrics inside the application. So that is what I mean with in-depth metrics in this case. What else do we have? So the infrastructure is completely new. Someone who has never worked with SDN and never worked with change routes is always thinking, what the hell is going wrong here? Why do I have this weird-looking process list when I'm on the system? So it's a new infrastructure, and people have to adopt and have to learn about this new infrastructure. You have to completely reconsider how you think about infrastructure that you're running at all. You need to learn the new concepts, which means when you start introducing somehow container technology into your company, be sure that you need the time understanding and learning the technology underneath. Otherwise, it would make no sense to run this afterwards somehow even in testing. It would make no sense. What we usually see is companies saying, or departments saying, oh, we have built a POC. I usually refer to that as a proof of concept. So we are able to have a system with somehow a container runtime engine, and we are able to run Docker containers or containers inside. Yeah, but how did you build the system? Oh, we logged in and changed the configuration file, restarted the service, and we changed some parameters for Docker itself. We added some parameters to this CTL. We disabled SA Linux because this was too hard to understand. Okay, this still is a POC, but it's not a proof of concept. It's just a pile of crap because you have built it in a manual pattern. So you can say it's a POC when you can destroy the POC and automatically redeploy it again. Then that's a proof of concept that you can really build it, maintain it, and easily reinstantiate from scratch. What are the benefits? Who's thinking about or already is in cloud? That's only a very, very few people. Okay, let's ask the other way around. Who's considering, not even doing, but maybe considering moving parts of the application out into cloud? Not really more people. Okay. Think about a company that considers bringing applications into the cloud. For example, you are a company being in Frankfurt and you have your data center in Frankfurt and you have customers in Sydney. So should your customer always connect to your Frankfurt-based servers, why not bring this front-end application near to the customer saying, I'm spinning up a system in that region using cloud services? The benefit when you deal with containers, you're very near to cloud-based technology and to cloud understanding how things are working. So it's more easy for you to migrate to any kind of cloud provider afterwards, even if you're not some hosted Kubernetes stuff, just doing some cloud stuff at all. The next thing is when there's issues with the application. So you have latency in the application, you get HTTP errors, you get wrong SSL certificate errors, stuff like that. Then the application developers know for sure this must be somewhere inside the application, not in the underlying operating system. The same is for the infrastructure developer, who have the opportunity saying this is not related to the application, this is fully related to the operating system, some upgrades went wrong. So it's more easy to identify where to dig for the problem due to the separations of concerns that we have infrastructure developer taking care on the infrastructure and application developer taking care on the application level. One more. It's just people have to use it. So when you do containers, you can limit the container within its capabilities. You can set kernel capabilities, you can limit it in terms of hardware usage, so you can place C groups on it, how many CPUs, how many gigabytes of RAM. If you don't do that, every container says, oh, that's nice, 64 cores, 128 gigs of RAM, I take as much as I can. Then your whole system saturates and you will get underneath OS out of memory errors. And it will just tear down processes in a weird order. And what we usually see in classical platforms, the first process that gets teared down and stopped by the kernel is, of course, the SSH daemon, so you can't log in and see what's happening, what's wrong. When you limit the container and the container needs more memory, it's just the container dying, it's not your system dying. So take care that people set policies on containers. It's a real benefit that you have in there. Secrets. Secrets are something where partly infrastructure developers say, we need secrets management. We want to have something like, within the secrets management, we want to have the certificates. We want to have some tokens and passwords inside. The application developers also need secret management for the same solution, so for placing certificates, passwords, tokens inside. So this is something that you can say this is a shared usage system. So it's built by the infrastructure team, but it's used by everybody. The application developer by themselves, they only need their CI/CD system, and they need access somehow to the container runtime engine API, please via API. The application developers will take care on building new releases, deploying new releases, reverting if new releases are broken. Try to do that in an automated pattern. Think about health checks that you build into the application and using proper API calls. Infrastructure developer take care on scaling. So how do we provide storage? How do we provide performance storage to the customer, which is the application development team? How do we do network? This is something that are completely unrelated to the application development, but this is work done by the infrastructure team. On the other hand, application developers should mention within their containers about kernel capabilities and C groups. So they should be aware that they know when we build a container, we must provide information on minimal uses of CPU, minimal amount of RAM, maximum amount of CPU, maximum amount of RAM. So that they are totally sure their container is working within these hardware restrictions. In the past, what is it that we had? Development is throwing a new release over the fence. While the release is in mid-air, developer shouts over to ops saying, catch it, take care, it's fragile. They do that via broadcasting, and ops is surrounded by that fence. And now everybody from ops is looking uphill, where does the release fall down so we can catch it because we have to take care it's fragile. Then we bring it into the platform, and within 8 hours afterwards, of course it's Friday evening by then, we get our first alerts by saying something's wrong on the platform. So when you do the modern way of dealing with containers, let application developers also deal with issues in the application, because they know how to revert, they know their code. We had that so often that we as ops people we're on call, we received the call from the platform, something is horrible broken, and afterwards we needed to call developers anyway because we said it's inside this weird PHP Perl code. We can't read that, so please fix the bug for us. So why should we have this communication proxy, an ops person being on call, when the developer can do the on call directly by himself? Take care on tooling decisions. What we usually learned at customers is there are three teams with at least three different opinions on how to use a specific tool. So the first team says we have to use Git for version control. The second team says no, we never did Git, and Git is hard when it comes to access right. Let's do that with SVN. We can make it on a directory basis, providing access to it. And the next one is saying, I have heard of neither can't we do without at all. So what I usually recommend is then each team must mention of another product 3 things why to use the other product. They are not allowed to talk about their preferred solution, but they should argue about the other preferred solution preferred by other teams. Makes it easier to identify where do people have issues with understanding a technology, with understanding and somehow a supportive application like a GitLab or GitHub Enterprise or whatever you want. Automate your CI/CD solution. Automation does not mean I have a CI/CD and now I'm clicking in an interface to get my pipelines. That's the wrong way. That's not automation. That's manual work. We had the talk by today. Manual work automatically means it's a bug. So instead, find a solution that allows you to define your pipelines in a text file next to the code base. So it's everything in one place. We sometimes have discussions to even put the documentation of the application into the repository where the application is hosted, including the pipeline. So everything is in one place. It's just a text file. Hopefully it's not XML. I don't like XML. That's all I have to say about XML. Hopefully it's just something readable and understandable, and I know how my pipeline is built. When I change the text file, my pipeline will change automatically. This is what I understand when it comes to automated CI/CD systems. For E in SSH do SSH and some commands that way, yeah. Hands-off platforms. I usually tend to name hands-off platforms and explain that to people afterwards by saying, when you log into any system via SSH, I will chop off your hands, and that's hands-off by then. So you can't connect to it anymore. No, I won't chop off hands, that's okay, but consider your platform being something fragile when you log in. It's broken when you log in. When you've logged in, okay, maybe with your own user, without sudo permissions, that's correct. You might have some less permissions cat's permission to view some files. At that time where you do some sudo commands, I expect that system to be undefined state, and optimally you should tear it down and spin it up again because it's in an undefined state. When you do really hands-off platforms, you're sure the system is in a way how it is built automatically. So the container got built and the container is just started, and you don't log into the container and do some configuration afterwards in the container after it has started. Learn about APIs, learn about how to deal with APIs. Hopefully it's REST APIs and not SOAP APIs. Learn about APIs, learn about how to secure APIs. Securing APIs with certificates. Certificates have a common name usually located to it. Based on these common names, you can provide different access right levels. So saying, there's a certificate that can just read some information, and there's a certificate that it can even change information. So am I allowed to do a GET or a POST request? So it's so super easy to do that with REST APIs based on certificates. So this is your trust. If a certificate somehow got compromised, revoke the certificate and make a new one, and then you're good to go again. As I already mentioned, containers allow separation of concerns. When building containers, please go security first. It's hard to implement in any kind of platform a security afterwards. We've seen it so many times. Developers developing, ops people deploying, people, QAler do tests on the platform, and then somehow security shows up and says, no, we have cross-site vulnerabilities, we have different other things, there's some OS information and a header from your web server, you have to fix that. So of course we have other issues with fixing security because we first need to fix the application, then we can fix the security. But when you build it right from scratch, that you consider the security first perspective, then you're on a safe way. And please, when you do, now it's Docker related, when you do a Docker daemon, don't give access to the Docker CLI. Giving access to the Docker CLI is like giving root SSH access to your platform. You can do anything. You can jump in a container, you can move things in a container, you can remove things, you can somehow rename containers when you don't do trusted registry. So I'm just downloading some Bitcoin miner and I will deploy it into our internal registry as our front-end server. And yes, of course, the front-end application is also inside, but my Bitcoin miner is now also running in production. That's cool, that's nice, I like that. And again, we talk about kata. So when we do containers, we still need the cultural change, how to view platforms, how to see platforms. When it comes to containers, there's even more need to automate the stuff. Don't do something manually on containers. That's a complete anti-pattern. You still want to have transparency and you want to deliver more transparency. You want to have business values, business information from your application into your time series data so business can also reuse these information and visualize their important parts. And of course, you still do everything agile, and now you're also building your infrastructure in an agile pattern. So the infrastructure developer also say, we want to build a huge cluster. Okay, let's start with the first node. Let's start with the first container. And then you grow over time and improve your platform. So this brings us now to the latest thing, which is container orchestration. So what's a container orchestration? The most simple one you can think of when you have Docker is Swarm. It just means that you have multiple nodes where your containers can run on. When you don't do that, and that one node hosts all of your containers, and when that one node goes down, all your containers are gone. So instead, you want to have some tooling at hand that allows you to spin up multiple containers on multiple container runtime engines throughout your infrastructure. And this is managed by a container orchestration engine. So what is it now that we have to do from an infrastructure developer perspective? We have to maintain the cluster. So it's no longer one standalone container runtime engine system. Now it's multiple systems of these. We take care on the hardware or the virtual machines in case that we still run on-premise. We take care on the network, so the software-defined networking. We provide storage, whether we use Ceph. Yesterday there was a talk about Ceph and also something about Gluster and what happened with Gluster, what did not happen with Ceph. So find a solution for you that is working properly based on storage. You will take care on Ingress and Egress. Who of you knows what Ingress and Egress is? Okay, so that's common wording. Ingress is the traffic that gets inside somehow a container, and let's say inbound traffic. Egress is the outbound traffic. So you want to ensure when you have a container running, definitely it's on an RFC 1918 network, so private IP address, not accessible from outside. You have to build something that gives you an outside component access to your internal running Docker system container. What else will infra development do? Infra development will take care that development teams receive tokens to access their namespaces. Maybe even namespaces which already have some tains set, some tags set, some constraints set. So for the testing department, you may not exceed a certain amount of CPU, you may not exceed a certain amount of RAM, you may not exceed a certain amount of storage, just as an example. And then you provide tokens so that the CI/CD system can access the namespaces properly. Application developer, nothing changes. They still handle their application, they build their application, they deploy their application. Application have health checks. Inside their namespace, they provide a service specifying what is the URL to check if the container is working or not. And based on these results, they might even build something like an automated revert process inside. And they say the new application doesn't work as expected, the health URL is not working, so let's automatically rotate back to the older version. Yeah, they will set the hardware limits on the containers. Secrets is still something that you can share within this infrastructure. Yeah, so what is it? Container orchestration allows you to run multiple instances of processes amongst multiple servers. So it's first done for high availability and of course for high performance, that you can place multiple containers on multiple systems for load balancing purposes behind a load balancer. What we had with Docker CLI is now something we have when it comes to Kubernetes, at least. With kubectl and kubeadm, just restrict access to these CLI tools, because this is even weird. This is like root SSH cluster. It's like cluster SSH, so that you have access to all of your cluster nodes within a single command. Instead, at least with Kubernetes, you want to do role-based access control. You want to have groups inside that, and you want to provide tokens for each of your users, so that the user is not really a person that is working with the code, but it's an application user from your CI/CD pipeline system, so that this system is responsible for talking to your orchestration engine. And again, the same pattern. When you have a rebalancing in such a platform, so for example, that server over there needs a hardware maintenance because it has a broken power unit, you want to first remove all instances off from that server to another server. It's not something like live migration you will do in a VM. Instead, the containers will be stopped over there and rescheduled somewhere else in my cluster. So then I have a free node and I can do my work on. And that's even worse, because now things are happening automatically. So tiering systems up, starting systems up, tiering systems down, and you can't work that fast to deal with that automation in a manual way. So please, hands-off platforms. The big question is, how much ops would you still like to do at all? So there are concepts like serverless, opsless, brainless, useless, painless, to be some positive wording on it. So there are companies that provide you with what you need to run infrastructure, so infrastructure as a service. So you can just say, okay, I'm paying that company over there to be my preferred vendor of infrastructure, and I will just use their API to spin up systems, configure them accordingly. When it comes to containers, you might get to a hosted Kubernetes platform and just say, I'm spinning up the container, the kubectl master, and then I have my nodes connected to it, which take care of my payload. So if you are in that pattern, it's more like, let's say, startup mentality. So startups usually don't have enough money to really fund a data center and lots of hardware. So instead they say, okay, we have 6 weeks of time, then the product must run on the platform, and we just go to some kind of cloud vendor and have everything running there. When you still have systems on-premise and they're already there, why not spin up a virtual machine playing around and identifying what is it that we can do with Kubernetes, with a container runtime engine, with a container orchestration engine? And we still consider, is this still something DevOps that fits into the kata of DevOps? So we have more changes in culture. We have some isolations where we don't collaborate anymore, because we say application is within application developers, infrastructure is within infrastructure developer, but yet these systems have to align and work properly. Consider upgrading your container orchestration engine. Is the code that is used to manage the container orchestration engine, is it compatible with the new version of the container orchestration engine? You have to check for that, so there's still collaboration needed, so we still need the culture on how to deal with other people. Automation, even more important. Automate everything. Don't do something manual in a platform where you do container orchestration. Transparency, it's the same like running a single container runtime engine. You still need to provide information and data to your different customers. So business wants to know what's happening inside the application, how many transactions haven't been processed, payment transaction, because that's important. That is what the company makes money from. So we need to know, do we have pending transactions in the platform? So also business transparency. Agility is the same. So no difference at all. There's one thing coming more to it where I say, please consider security right from scratch. So when you plan on your Kubernetes cluster, for example, and you plan for role-based access control and you plan for namespaces, take care that you get first to security and that you get the okay on running a platform in that pattern. They might help you securing somehow systems, the infrastructure underneath, so that nobody can use somehow kubeadm, kubectl command line interfaces. So complex platforms, it's something that will happen by itself. You start with a simple platform and you look on it 1 year later and you say, wow, it's grown. Many new things next to it, new components coming. And the problem is you can manage complex things only when you split them down into the most simple thing you can manage. And that is the challenge we're now running in. Something like Kubernetes is a complex platform. It consists of multiple plugins that are exchangeable. So nowadays, I suppose it's still Docker-D being the default Docker runtime engine, but you can replace it with CRI-O, so it's another container runtime engine. You want to understand what are the differences between now Docker and CRI-O. Network plugins, what kind of network plugin you want to use? Flannel, Weave, Calico, something else? What else is it? You have some operators that allow you to deal more easily with the platform. What kind of operators do you want to use? So cut everything down into the most simple to find problem, because when you can manage it in a simple way, then you are able to also manage a complex platform. That's the big thing you have to take care about. So from my perspective, when it comes to containers and a containerized world, DevOps is not dead. It's even expanding. It's even more required compared to old platforms, where you still say, okay, we do some DevOps, but there are application managers that don't do DevOps. They just change some settings inside their application, and they do the work as they want. The problem is the steep learning curve. So it's about containers itself. What is a good container? What is a bad container? How to store a container? How to sign a container? It's certificates. It's for some people it's even learning Git or maybe understanding Kubernetes. Oh, and the SDN, of course. So what is BGP, by the way, and how it is working? What kind of network do I have now in my container orchestration engine? Is it layer 3 or layer 5? Oh, what was layer 3 and layer 5, by the way? There was this OSI model. Yes, I know. The one thing is the hardware, the other is the application, and there are plenty of levels beneath. But you need to be aware of that. You need to have at least some basic knowledge on that. What are the benefits when doing DevOps in general? And of course, also in the containerized world. Well, there's now this buzzword bingo. You can put out your papers. It's time to market, total cost of ownership. So when you do faster deployments and you recognize a deployment is broken and you easily just revert that deployment automatically, you can still make business value. Maybe not with a new version of the application, but at least your platform is still functional. Customers can still buy and use your platform. So that's the total cost of ownership. Deploying new applications by this agile development method easily gives you the advantage over a competitor who doesn't do agile development, who needs 6 months to deploy a new feature, making that button blue instead of green, just because people can't read it. The same things like, as usual, automate everything and do the security first. What I had in the past, so let's say it this way. In one of my very first, it was my second job in IT. I had someone, so I was working as a consultant. It was in finance area, so wearing a suit and a tie every day. And one of my colleagues came to me and mentioned, Martin, the most important principle when working with platforms is KISS. And this is what I lack at the moment. When I see people, younger people building platforms, they completely neglect the KISS principle. Keep it silly, simple, stupid, so easy to understand. So building platforms, how did I mention it? As simple as maximum possible and as complex as minimal required, but that's minimal requirement. So build everything so that you can show it to your mother and explain it to her, and she says, yes, I understand it. That's a simple platform. Definitely. Okay, when your mother is maybe a COBOL coder, everything is simple, but okay, some conclusions. So the first thing is, when we do containers, DevOps is not dead, it's even more required than before. What is it that I mentioned, DevOps? DevOps basically is the culture of communication, the culture of behavior, the culture of attitude, the culture of listening and asking, and not yelling, not complaining, and not insulting. So, but this is something that you can't do with technology. There is no way that technology changes the behavior of people. I haven't seen that so far. So it's the problem that you have with people. I found this quote from James Gustav Spieth. He is more in he claims himself being an environmental lawyer. So he's more dealing with global things that happen on Earth. But what I really like is that he mentions he thought about just research enough and you will find a solution for the problem, but he also found problems which are not solvable by engineers or, as he mentioned, by scientists. It's the culture, how people think. Here he says the most top environment problems: selfishness, greedy, and apathy. So when you deal with these people in a company and you want to implement DevOps, forget it. It's not possible. You have to have motivated people that want to change something. You need supportive people that are also not just looking for the next position in their job, but who are eager to help and support their colleagues. Waiting till the photo is taken. Okay. So, classical DevOps means we do collaboration. We have this kata, we have this DevOps kata at hand. So we have established a culture of communication, collaboration. We have shared tooling in place, so not everybody is doing his own thing, that we share responsibilities for tooling. We have some separations of concerns, but most things are done together as a team. Team not in German term. In German term, it means toll ein anderer macht's. In English, it refers to great someone else is doing the job. But really as a team, collaborating team. When it comes to containers, the only thing you have already some strict separation of responsibilities. So application developers take care on applications, infrastructure developer take care on infrastructure. They run together on a single platform, but due to that isolation level, it's more easy to identify where is the issue. Is it within the application or is it within the infrastructure? You still have shared tooling, and you have more like an API-based collaboration. Infrastructure developer provide API access to application developers. And the same thing happens when you run containers in a container orchestration engine. You still have the strict separation, you have the shared tooling, nothing changes, it's just that you run containers on multiple hosts. With that, I'm finished too early or in time? I have no idea. In time, okay. So with that, thank you for being here at OSDC. Thank you for listening to me. Sorry for being so boring compared to James.
So we still have some time for questions. Any questions?
Okay, I have a question. Who's already running containers in production? Around about 50%, okay. Who would do that again? That's less people than before.
Okay, no questions?
No questions.
It's the last chance. OSDC is over soon. Okay,
One question.
One question.
So I will refer to two previous questions. You ask how many people use cloud, and then you ask how many people use containers. Based on the answer, I guess that so many people use containers on bare metal.
Oh, we can check. That's quite easy.
Yeah.
Okay, so who's doing cloud? Everybody raises their hands who's doing cloud. Okay, that's only, no, there's few people than before. Okay, so that means when people run containers, we have more people running containers than running on cloud, means most people here run somehow on-premise. For whatever reason, maybe infrastructure was already there. We have customers that are not allowed to go into cloud for privacy and regulatory legal reasons, for example. Also makes it difficult. It's Germany. Welcome.
Okay, any questions? Come on, the last chance.
Last chance.
Okay, thank you very much, Martin.
Thank you.